All right, get ready to explore the world of image classification because today we're doing a deep dive into your project, using it to identify edible plants. That's next level stuff.
It really is a fascinating area with so much potential, and using EfficientNetB0 and MobileNet for this
Yeah.
just made it that much more exciting.
Two models. Wow, you really went all in on this, huh?
Yeah, I did. Tackling it with both EfficientNetB0 and MobileNet was a really interesting challenge.
Before we get into the nuts and bolts of how you actually pulled it off, I want to talk about the why. This isn't just about knowing which mushrooms to pick for dinner, right? This
Right.
is about building a model that's accurate because the real world stakes are high. Misidentifying a plant, well, it could mean a really bad stomachache or even worse.
Absolutely, you hit the nail on the head. The consequences of a wrong answer in this scenario could be really serious. So that focus on building a reliable model and minimizing those risks, that was there from the very beginning.
And your Jupyter Notebook lays it all out step by step. I love how you didn't just jump into the deep end of the code. You made sure your setup was rock solid. You made sure TensorFlow is up to date, which is so crucial for a project like this.
It's like making sure your AI's operating system is running the latest, most stable version, right?
Exactly.
And then bringing in libraries like NumPy and Keras, it's like choosing the right tools for a very specific job. NumPy is perfect for handling all those numerical calculations with the images, and Keras helps build that model framework.
It's like building a house. You need the right tools for each stage of the process. Otherwise, the whole thing falls apart.
That's a great analogy.
You even went a step further and set global variables like image size and batch size right from the get-go. Why was that step important for your process?
Well, consistency is super important in machine learning, right? So by setting those variables early on, it basically acts as this baseline. It makes sure everything is standardized throughout the entire project and eliminates any inconsistencies that might pop up later down the line.
Makes sense. So you've got your toolkit ready, but just like with any project, it lives or dies on the data. You went with Kaggle for this one, so tell me, what made this specific data set of edible plants stand out as the perfect ingredient?
So a few reasons, actually. First off, the sheer size. I mean, we're talking about thousands of images across this diverse range of edible plant species. And second, the images themselves were really high quality. Plus, they were accurately labeled, which is crucial for training a model that's actually reliable.
You can't bake a cake with spoiled milk, so it sounds like this data set had it all. But then you took it a step further, meticulously prepping that data like a chef before a big cooking competition. Can you walk me through the steps you took to make sure that data was prepped to perfection?
Data preparation is honestly where the magic happens in a project like this. So I started by verifying the directory contents and making sure all the class labels were correct. And then came the pre-processing stage, resizing all the images, encoding them, and normalizing them to make sure everything is on a level playing field.
I love that analogy. It's like prepping vegetables before you saute them.
Exactly.
Make sure that everything cooks evenly.
Exactly.
And I love that you didn't stop there. You split the data into training, validation, and test sets. Why was that split so important?
That split is super important for building a model that's actually going to hold up in the real world. It's like tasting your dish at different points while you're cooking it. You don't just want to taste it at the very end, right? You got to make sure it's good at every stage. So the training set is where the model does most of its learning. The validation set is like a mid-cooking check. It helps fine-tune the training process. And then that test set, that's the final exam, that shows us how well the model generalizes to new data, the stuff it hasn't seen before.
Validation is definitely the moment of truth for any AI model. But before we dive into those results, I have to ask about something you did that I found really interesting. You did a series of visual checks on your data before you even started training the models. It's like you were peeking under the hood, making sure everything looked right before you hit the gas.
Yeah, exactly. Those visual checks were all about confirming that what my eyes saw actually matched up with what I thought the data represented.
It's like a sanity check.
It is. It's easy to get lost in lines of code, you know. Those visuals, they really help ground you in the reality of the data.
So walk me through it. What did those checks actually look like, and what were you looking for?
Okay, so first I created what's called a grid display. It's basically a sampling platter showing one image from each of the 35 edible plant classes in the data set. It's a really quick and easy way to confirm that, first of all, the data set's actually diverse, that it's representative of all those different plants, and second, to spot any glaring issues right off the bat.
So did anything surprise you in that initial scan? I mean, were there any plants you weren't familiar with, even with all your research?
Oh, for sure. I mean, there's so much variety out there in the world of edible plants.
Right.
Even as someone who spends a lot of time studying plants, there were definitely a few surprises in that grid display.
I love that. It's a good reminder that there's always more to learn.
Always.
Okay, so you've got your sampler platter, you're getting a sense of the spread, but then you decided to zoom in a little bit, right?
Exactly. I wanted to look closer at multiple images from a single class at a time.
Okay.
Like you mentioned ramsons earlier, the wild garlic.
Yeah.
By looking at a bunch of different pictures of ramsons, I could get a better sense of the natural variations that exist within that one specific type of plant.
Because even within one species, there's going to be differences depending on where it's growing, the age of the plant, all of that.
Precisely. And to capture those variations even more comprehensively, I did a third check, looking at multiple images from multiple classes, all side by side.
Oh, wow. Okay.
That really helped me understand how different species compare and contrast visually,
I see.
making sure there were clear distinctions, because that's what the model ultimately uses to learn.
So smart. Those visual checks, they seem so simple, but they're so crucial to making sure your AI has the best possible visual vocabulary.
Absolutely.
The data is prepped, visually confirmed, and now it's time to build the brains of the operation, the model itself. And for your first attempt, you went big, EfficientNetB0. What made you choose this particular architecture? What made it stand out as a good fit?
So EfficientNetB0, it's kind of a rock star in the image classification world. It consistently delivers high accuracy, and it's a pre-trained model.
Oh, okay. So it comes with some knowledge already baked in.
Exactly. It's like it's already got a head start in understanding the nuances of image recognition because it's been trained on this massive data set of images.
It's like giving your model a crash course in visual literacy.
Yes, exactly. But even with that pre-trained knowledge, I didn't just leave it at that. I froze some of the model's layers and then added my own custom layers on top, fine-tuned for this specific task.
So it's like taking a chef who's already really good at what they do and then teaching them some new specialized techniques.
A great way to put it, those specialized layers were designed specifically for edible plant recognition. So we're basically taking this model that's already a visual whiz and then focusing that expertise even more.
And the initial results, they were pretty impressive. 88% accuracy right out of the gate. What was going through your mind when you saw those numbers?
I was really happy with that. Getting 88% accuracy on the first run with EfficientNetB0, that was a really good sign. It meant I was on the right track. But it's important to remember that those were just the initial results from the training phase.
Right, because then comes validation, the real test. That's where you see how well the model performs on a dataset it's never seen before to make sure it wasn't just memorizing the training data. So how did EfficientNetB0 handle that? How did it do in the validation stage? So the moment of truth, how did EfficientNetB0 handle the validation stage?
Really well, actually. It consistently scored in the high 80s, accuracy-wise, on the validation set, which was great.
So it generalized, well, it wasn't just memorizing those training images.
Exactly. It was able to apply what it learned to new data, which is what we want to see.
Music to a data scientist's ears.
Yeah.
But you didn't stop there, did you? You went on to build a whole other model, MobileNet. Why explore a second architecture? What was the thinking there?
Well, as the name kind of gives away, MobileNet is all about efficiency and speed. It's built to run smoothly on devices that have more limited processing power, like smartphones. So, thinking about the real-world applications of this project, I wanted to see how a model like MobileNet would handle the task of identifying edible plants, especially with that speed and efficiency in mind.
So you were already thinking ahead to someone maybe using this out in the field, like an app on their phone that could identify plants on the go.
Exactly. That was the idea.
Smart. So when it came to actually setting up and training MobileNet, did you have to make any significant changes to your process compared to EfficientNetB0?
The overall process was similar. But because MobileNet has a different architecture, it needed its own specific configurations. But I still used pre-trained weights and added those custom layers fine-tuned for edible plant recognition, just like I did with EfficientNetB0. And I used the same training data so I could directly compare how the two models performed.
A head-to-head matchup. So how did MobileNet do? Was it able to keep up with the high bar set by EfficientNetB0?
It did a really good job. MobileNet's accuracy was a bit lower than EfficientNetB0, somewhere in the high 70s to low 80s, but still really impressive. And the key thing, it got those results with much faster processing speeds. So, yeah, I'd say it's definitely a contender for real-world use, especially on mobile devices.
So you've got two successful models, each with its own strengths. EfficientNetB0, the accuracy superstar, and MobileNet, quick, efficient, perfect for on-the-go use. That's incredible. Looking back on the entire project, were there any hurdles you had to overcome? What were some of the biggest challenges you faced while building these models?
I think one of the trickiest things was finding that sweet spot between accuracy and efficiency,
Hmm.
especially with MobileNet. We want it to be fast, but there's always that trade-off, Fine-tuning the model to be super accurate while making sure it was still lightweight and fast, that was a fun challenge.
Finding that balance is an art form in itself. Now, was there anything that surprised you during this whole deep dive? Anything unexpected that you learned along the way?
Honestly, I was blown away by how much of a difference the data preparation and augmentation made. I knew it was important, but I didn't realize just how much those steps could impact the model's accuracy. It really drove home the point that getting your data right from the start is absolutely crucial. It's like laying the foundation for a house.
You've taken us on quite the journey today through the world of image classification, and we've seen how this technology can be used to identify something as essential as edible plants. You've built two impressive models and really given us a lot to think about. It makes you wonder what other potential applications are out there waiting to be discovered. That's the beauty of a deep dive, isn't it? It sparks our curiosity and leaves us wanting to learn more. So until next time, keep exploring, and thanks for joining us.